Hi, I'm Isabella Alino, and today I'm going to be talking about the methods of atmospheric water harvesting. It's one of the most efficient, sustainable, cost-effective, and promising techniques for addressing the world's water scarcity crisis. Over 4.3 billion people around the world struggle to access clean, abundant, and safe drinking water. Yet, our atmosphere contains approximately 13 quadrillion liters of water in the form of water vapor. This offers a viable solution to meet the demand for drinking water across arid and high humidity regions. The first method I want to talk about is condensation. In this method, fans pull air into a chamber and towards a cooled plate. This plate works similar to a cold drink on a hot day when water droplets condense from the outside of the cup. Warm air hits the cold surface and the water vapor turns into water droplets. The cold droplets are then collected and stored. This method works really well in humid areas, but it uses a lot of energy, so it's not very common. This next method is sorbent-based atmospheric water harvesting. Some materials called sorbents or desiccants naturally absorb water from the air. You may have seen desiccant or silica gel packets in things like beef jerky or in shoeboxes, where they're used to keep the environment dry. They're also used to absorb water and harvest it from the atmosphere. After they fill up, heat, often from the sun, makes them release the water, which can then be collected. This can work even in dry climates, and is more energy efficient, so it's more common. One of the most common methods is fog harvesting, which extracts water from fog particles. Many organisms actually use this method to collect drinking water, like the Namib desert beetle, spider silk, and cactus spines, which all have surface features that enable them to capture water from fog. We implement this technique using meshes and screens. Fog particles condense onto these surfaces to form water droplets. The efficiency of fog harvesting is influenced heavily by fog density and the size and shape of the nets, making it a simple and cost-effective method for collecting water. This method is fairly new. Metal organic frameworks, or MOFs, are made by linking metal atoms with organic molecules to create a kind of microscopic sponge. Even though they look like a fine powder, each grain has a huge internal surface area, which means they have lots of places for water molecules to stick to as air passes through. Adsorption is where the water clings to the surface inside of the pores. When MOF is heated by sunlight, the water comes out through desorption and can be collected as liquid. MOFs work even in low humidity, which makes them promising for extracting water from dry air. This last method isn't really its own unique method, but rather it's an innovation on the desorption process. Recovering the water from sorbents and MOFs usually requires a lot of heat and time, and existing designs rely on heat from the sun, but this can take hours or even days. Researchers recently developed a method to do so quickly. They created an ultrasonic device that emits ultrasound waves, tuned to shake water molecules out of the sorbent or MOF. This shortens an hours or days long process to minutes, and it makes atmospheric water harvesting a lot more viable as a solution to the water crisis. Thank you so much for watching. I've been really into atmospheric water harvesting since I wrote a paper on it a few years ago. There's still so much exciting innovation happening all the time. I hope you enjoyed learning about it as much as I have. Bye!